you might get head or tail, and you can also represent them as 0 or 1. And here you can write like the probability and the experiment, right? Let's say the probability of north is 1 by 4 and east also it is 1 by 4. So you can say that the mass PMF here, there is no mass, means the gradient will be flat in the cumulative density function.
Hello friends, welcome back to day 40 of the 100 days of hell with Python algo trading. We have completed 40 days, that is 40%, and that is absolutely amazing thing for all of us. And I would also like to say that it is T minus 61, means the second round of the restart. And today we will understand one of the most confused topic, which is probability distribution. So many people get confused in this and they think that it is tough, it is complex. But friends, I would like to say it is not tough, it is not complex, it is very easy. You just have to focus for 1 hour, and I promise that after 1 hour you will understand this topic thoroughly. You will have a deeper insights in this topic after this session. I can guarantee that. But the only condition is that you have to focus for the next 1 hour. So whenever I have to understand any important topic, what I do, first of all, I plug a headphone, then I maximize my screen. It can be a phone screen or a monitor screen. Then I sit and watch the whole session without any distraction. And that is the most important thing for me. So if you really think that it is tough, then please follow the steps and you will see that you get all the points, right? And today, this is a beautiful Saturday morning in Singapore, and I'm really excited to make you understand this topic and to demystify the probability distribution function. So without further ado, let's get started. Okay, so now what we will do, we will start from very basic and we will build up, and then you will see that what you have achieved in just 1 hour. So first of all, to understand the probability distribution functions, you have to know what are variables, right? Constant means we have a value x is equals to 50 and this will remain constant. But what is variable? Let's say we have y is equals to 10x, right? Now let's say x is the variable. So whatever the value you put for x, the y will get changes, right? So for the x equals to 2, y will be 20, and for x equals to 3, y will be 30, right? Means we can say here x and y are the variables and this x is constant, right? So for now it's clear. Now what we can say these are the algebraic variables, right? But now we are learning probability. So in that we have another type of variables, and that is known as the probability and statistical variables. So those are represented as the capital X, right? Hope it's clear so far. Okay, so now let's have an experiment. You toss a coin and you will have two outcomes, head and tail, right? So let's say you have a coin and you will get two results, two outcomes, head and tail. And you can also write head equals to 0 and tail equals to 1, correct? Now, how you can write this? You can write like x equals to 0 and 1. Or let's take another example of a dice. Let's say you roll a dice, right? And what are the possible outcomes of a dice? You can have 1, you can have 2, 3, 4, 5, and 6. Means you can write like y is equals to 1, 2, 3, 4, 5, 6. And here y is the variable, right? Okay, now we have types of variables. So we have just understood that we have algebraic variables, or we can say we have probabilistic or statistical variables, right? Simple. We can represent algebraic as x or y, the small, and for the probabilistic and statistical variables, we can represent them as capital X, capital Y, right? Now let's discuss what are random variables in probability and statistics. Random variable means the random outcome from any experiment. Let's say you flip a coin. So there are possibly two random outcomes. It might be a head or it might be a tail. Or let's say you flip a dice. So there are possibility of 6 random variables or 6 random outcomes. It can be 1, 2, 3, 4, 5, 6. And the probability is 1 by 6th of every outcome, right? So you can say when you flip a coin, you might get head or tail, and you can also represent them as 0 or 1, right? Similarly, when you roll a dice, you might get 1, 2, 3, 4, 5, 6, correct? And you can represent this as, let's say, x is equals to 1 or 0, or you can write like x is equals to 0 or 1, or also you can write like y is equals to 1, 2, 3, 4, 5, and 6. So these are the random variables in statistics and probability. Okay, let's say you execute a trade, you might buy or sell, but the outcomes are only two. You might be profitable or you might be in loss, right? So you can write profit as 1 and loss as 0, means there are only two possible outcomes, the loss or profit. Now let's proceed and understand the types of random variable. So we have two types. One is discrete and another is continuous. So when we talk about discrete means you have integer values. Let's say we just talked about the coin, so you had 0 or 1 as the possible outcomes. We talked about the dice, you have 1, 2, 3, 4, 5, 6 as the possible outcomes. So again, we talked about the trade, you might be in profit or you might be in loss. So you can represent them as 0 or 1, right? So similarly, when we talk about continuous random variables, there are multiple examples. The best and the famous is the height of all the humans in the world. So it can be 6.2, it can be 5.2, it can be 5.42, it can be 5.432, right? So you can write like 5.2, 5.23, 5.234, means these all are continuous. There is no discrete value. Hope until this it's crystal clear. Because for the main topic, that is probability distribution, you have to have a thorough understanding of these basic principles. Now let's understand what is probability distributions. So what I'll do not repeat so many definitions, formulas. I'll try to make it as more as intuitive, right? So that you get a clear picture of the what is happening here. So what is probability distributions? Let's say you roll a dice, right? And these are the possible outcomes, right? So when you make a table, that is known as the probability distribution. Or you can say when you represent them as any table or a graph, it is known as the probability distribution, right? Okay, let me show you. Let's say you have this graph and here you have 1, 2, 3, 4, 5, and 6. And here you have 1 by 6, then 2 by 6. So the probability of coming 1 is 1 by 6. Similarly, of 2 also 1 by 6. Similarly, for 3 also same. Like for all the outcomes, it is same. That is 1 by 6, right? Okay, now let's understand the probability distribution functions. So basically, here we have two types. One is probability mass functions. These are also known as PMF, right? Another we have is probability density functions, and these are also known as the PDF. Make sure you don't get confused between this PDF and this PDF. Some books or some tutors also write it as the PDF, but basically most of the time this PDF, this probability density function is known as the PDF, right? So we'll take this one. Now, for both these functions, we can find out cumulative density function. What is cumulative density function? And this is also known as the CDF. Again, first we have the probability distribution of any experiment, right? Then we have two functions. The first one is probability mass function and the second one is probability density function. And for both the PMF or PDF, we can find a CDF, that is cumulative density function. Now, one very important thing to note that PMF is only for the discrete random variables and this PDF is only for continuous random variable. So we can say this is for the example, this is for, let's say, a coin experiment or a dice experiment. Similarly, this is, let's say, height of humans and all those other examples, right? Until now, it's all clear. It should be very clear. We have probability distribution function. In that, we can have two types of functions. For discrete variables, we have PMF, probability mass functions, and for continuous variables we have PDF, probability density functions, and for both PMF and PDF we can find cumulative density functions, CDF. Now before proceeding further, let me explain you what is the meaning of this cumulative. So for that, what I will do, I'll explain this with the help of 3 real life examples. So let's say first example is a coin. So when you toss a coin, you have 2 possible outcomes. One is head, another is tail. Let's say you consider h equals to 0 and t equals to 1, right? So how can you write this? You will make a table, right? And here you can write probability and the outcome. So for the outcome 0 means head, you have a probability of 1 by 2, and for 1 also you have 1 by 2, right? This is the normal probability, right? But when we add another column and we will call it as the cumulative probability, means first you will have 1 by 2 and second you will have 1, means 1 by 2 plus 1 by 2, right? Means in cumulative you can range from 0 to 1. You add that value and all the previous values, right? Let's take another example. So for example, you throw a ball in the sky and when it comes back, so let's say ball throw. So when it comes back, after it is landed on the ground, right? Let's say this was the ball you throw. After it is landing on the ground, now it has basically 4 options that which way it will go. Like it can go to north, it can go to south, it can go to east, or it can go to west, right? We don't know that in which direction it will go, right? So it is also a random experiment. So we can create a table, right? And here you can write like the probability and the experiment, right? Let's say the probability of north is 1 by 4. Similarly, for south is also 1 by 4. Similarly, for west also it is 1 by 4, and east also it is 1 by 4. It is the normal probability. But when we talk about the cumulative probability, how we can write CP? Okay, for the first it is 1 by 4. For the second one we will add and the previous 1 by 4 also. So it will be 2 by 4. For the third it will be 3 by 4, and for the last it will be 4 by 4, means 1. Hope now it's very clear that we are adding all the previous outcomes, right? So okay, now I guess we are good to proceed further. Okay, now let's first understand this PMF, probability mass function, and we know that it is only for the discrete variables, means we can take the example of a rolling of dice, right? So PMF, probability mass functions, and let's again take the example of a rolling of a dice. So what I'll do now, I'll draw a plot, and here I'll give, let's say 1, 2, 3, 4, 5 and 6, correct? Similarly, here I can write like 1 by 6, 2 by 6, 3 by 6, right? Now we know that the possible outcome of a dice is 1, 2, 3, 4, 5, 6. So how I can draw this? I can draw like for the 1 we have 1 by 6 probability. For 2 also we have same. For 3 also we have same. 4 also we have same. 1, 2, 3, 4, and for 6 also we have same. Means for all the outcomes we have the same probability, right? Now what I'll do, so instead of writing this 1 by 6, what I will do, we know that 1 by 6 is equals to 0.167 around. So I'll change the scale, this one, and what I will do, I'll write here 0.2, 0.4, 0.6, 0.8 to 0.2, 1.0. Okay, means this is a little bit like this is here, you can say it is 0.16. Just understand what I'm trying to say, right? This is the PMF, right? Now if I want to draw the CDF of this, right? How can I do this? CDF means cumulative density function, right? So what I will do, I'll again create a plot and I'll write 1, 2, 3, 4, 5, 6. So now we have learned already that in cumulative what we do, we add the previous also. So, and here also I'll take the scale as 0.2, 0.4, 0.6, 0.8 and 1.0, correct? So when we roll a dice, what is the probability of 1. We know that it is 1 by 6 and that is equal to 0.16. So I can plot the plot here. 0.16 means somewhere here, and I can draw like this, right? Now for the 2 also it is same exactly, means it will be around when we stack this. So what I will do, I'll stack this previous 2. So here I can write like, I can just draw, it will be stacked on top of this, right? This one. So it will be like this, somewhat, not exactly but somewhat. Now again for the next, we'll stack this on the top, so it will become like this. It will be stacked, and ultimately for the 6 it will reach almost 1. So means ultimately the total cumulative frequency should be 1, the last one. Okay, now what happens? So when we always roll the dice, what happened? The 3 and 4 disappeared. We have only 1, 2, 3, 4. 3 and 4 is not visible. So whenever we roll the dice now, we will be having only 1, 2 or 5, 6. For now it's clear. This is PMF and this is CDF, right? Now, for example, this 3 and 4 is disappeared. So now how I can draw this? I can draw this like, this is 1, 2, 3, 4, 5 and 6. And we know that we have 1, we have 2, 3, 4 is not there, and then we have 5 and 6. So it will be something like this, and here we have like 0.16, and you can take 0.2 here, right? 1 by 6, correct? Now for this, what will be the cumulative? Okay, actually apologies for the oversight. It will be not 1 by 6, it will be 1 by 4. Why? Because we only have 4 outcomes, and we have only 4 outcomes means it will be 1 by 4. So you have to write like 1 by 4, or you can write 0.25. Now let's draw the CDF of this one. So the CDF will be 1, 2, 3, 4, 5 and 6. Similarly here also 0.25, 0.5, 0.75 and last one. So how you can draw that? You know that for 1 we have, so you can draw 1. For 2 also you have this, but we know that 3 and 4 is missing here, right? So we have to draw this gradient as it will be flat here, this gradient. There will be no increase here. Then for the 5 and 6 it is like again increasing. So for 5 it will be like this, and for 6 it will be like approximate here, this one. So you can say that the mass PMF here, there is no mass, means the gradient will be flat in the cumulative density function, right? So I think now it's crystal clear, because I tried my best to give you the clear intuition of the PMF probability mass function and cumulative density function. So here there was no mass, means, and the gradient means slope. Slope means hypotenuse, means perpendicular upon base, or we can say rise over run. The gradient or slope is same. Okay, now as we have covered the probability mass function, let's move to the PDF, which is probability density function. So this is the completely theoretical data of the runners and the probability of their finishing time. So here you can see that we have PDF here, and here we have CDF, and this is the mean time. So we can say that the mean is around 240, right? And the probability is around, you can say around 0.13 or 4, right? So okay, now we will try to find the CDF from the PDF, right? So we will try to find the CDF from PDF, and let's try to understand the relationship between the PDF and CDF, right? So what I'll do, so here you can see that this is the 50% area, right? So you can say this is the 50% proportion of the finishing time, and the probability density is 0.13 approximate. Similarly, if you try to find out at the 240, which is here, not the exact value, but approximate, which is around 0.5. And we know that this is the normal distribution, and in normal distribution, bell type graph, and for that we have a S type CDF, right? S shape. So, and we know that the maximum density is at 240 minutes, right? Means the most runners will be able to complete the race in 240 minutes. Very less runners will be covering in around 150, or very less will be covering in around 325. right? So we can say the mean is around 240, and that is the mean of the distribution, right? And similarly, the cumulative probability is also 0.5, right? Means we are covering 50% proportion. Also, let's take another example. Let's say you are taking for 25%, right? It was 50%. Let's say you take 25%. So it may be here, right? This area is 25% is around 210. And if you check here, you will find that the same cumulative probability for that, right? It's around 0.15, you can say. Means we are able to find cumulative probability from the PDF. Now, what if we try to find the PDF from the CDF, right? Can we do that? Let's try that. So what I will do, I'll just zoom it out a little bit. This one, CDF. Now what I'll do, we know that the mean is around here, which is around 240. And we also know that the gradient is highest at this place. Means the higher the gradient, I will write here, or the slope, right? So means the higher the gradient, is equals to higher density. Correct? Now, how do we find the gradient or the slope? We know that it is the rise over the run. So gradient is equals to rise run, or we can say hypotenuse is equals to perpendicular upon base. Now let's take 2 points here. I'll take 1 point here and another here. So this is 240. So I can take it as let's say 244, this one, and this I'll take it as 236. So similarly, when we talk about the y-axis, I can take it as a 0.55. Means this is 0.5, right? So this point and this point, so it will be 0.45, and this can be 0.55, approximate, right? So when I try to find out the rise over the run, it will be 0.1 upon 8, approximate, right? Which is equals to 0.13, right? Approximate 0.13. And we know that the maximum density is at around 0.13. Means we are able to find the PDF from the CDF also, right? Means the PDF and CDF are highly correlated. Means what we can say that if we want to find the CDF from the PDF, you need to integrate this any area. Means you have to find the integration, right? You can simply write to find the CDF from the PDF. You can simply calculate the integration. It is minus infinity to x and fx, which is equals to capital Fx. Just consider it as the small fx, and this will be capital Fx. So when you calculate the integration of PDF, you will get the CDF, right? Similarly, when you want to find out the PDF from the CDF, so means what you can do, you can simply calculate the differentiation, right? So the differentiation of fx upon dx, you will get the fx. Let me also enclose this in another square. So the conclusion is that when you find the area of PDF, you will get the CDF, and when you find the gradient or the slope of CDF, you will get the PDF. That's the simplest form of interpretation or the intuition. Hope it's crystal clear. And if you have any questions, please let me know. We can again discuss this, right? So now you must be having a clear picture that what is PMF, probability mass function, what is PDF, probability density function, and what is CDF of both the PMF and PDF.